Okay children, we discussed two types of reactions in last video. Now this is the third category, this is the third type, this is displacement reaction. Okay, now what is displacement reaction? Okay, displacement, from name it's clear, one thing displaces another. Okay, so here in displacement reaction, more reactive element, okay, more reactive element displaces less reactive element from its compound. Okay, in displacement reaction, more reactive element displaces less reactive element from its salt solution. Okay, for example, this reaction we have done this reaction, okay, in class 8 also. Copper sulfate, we all know copper sulfate, it is blue in color. So when we treat iron nail or iron filings with copper sulfate solution, remember this, for reaction you need a medium, so copper sulfate salt solution. Okay, now here, because iron is more reactive than copper, so iron will displace copper from its salt solution or from its compound, and we get FeSO4, okay, plus FeSO4 plus copper, ferrous sulfate plus copper. Now during this reaction, what changes you can observe? Okay, the three changes we can observe during this reaction. The first change is the color changes. Copper sulfate, this is blue in color, and ferrous sulfate, we already discussed, it is green in color. So the first change we can observe, that is the color change. Color changes from blue to green. Okay, the second change, the copper which is displaced, it deposits over iron. Okay, copper is reddish brown in color. Okay, so reddish brown coating of copper over iron nail or iron filings. And third change, because this reaction is highly exothermic, so if we'll touch the base of test tube or the beaker in which reaction is taking place, we can easily feel the change in temperature. Okay, why we can easily feel the change in temperature? Because this reaction is highly exothermic. Okay, I'm repeating, displacement reaction, when more reactive element displaces less reactive element from its salt or from its compound solution. Okay, so this reaction, iron plus copper sulfate gives FeSO4, ferrous sulfate plus copper. Okay, during this reaction we can observe three changes. Copper sulfate, it is blue in color. Ferrous sulfate, it is green in color. So color changes from blue to green, that is the first change. Second change, copper, it is reddish brown in color, so reddish brown deposition of copper over iron nail or iron filing. Okay, this is the second change. Third change, because this reaction is highly exothermic, so we can see or we can feel the change in temperature by touching the base of the test tube. Okay, the large amount of energy is released during this reaction. Okay, now I'll give you another example of displacement reaction, children. Okay, another second example of displacement reaction. For example, reaction of metal with acid. Okay, now during this reaction of metal with acid, we can take zinc, Zn, plus H2SO4, sulfuric acid. Now we all know zinc is more reactive than hydrogen because zinc is placed above hydrogen in activity series. So here zinc can displace hydrogen from acid and we'll get zinc sulfate. Zinc sulfate is ZnSO4 plus ZnSO4 plus hydrogen. As hydrogen is gas, so we can make arrow which shows it is gas, it escape out. Okay, during this reaction, children, This is also highly exothermic, so large amount of heat is released. Okay, hydrogen is released. We know how to test the presence of hydrogen. If we'll bring burning matchstick near hydrogen, it burns with pop sound. Okay, and grayish substance zinc sulfate is formed during reaction. This reaction is highly exothermic reaction. Okay, so this is also displacement reaction. Okay, now another example of displacement is copper plus silver nitrate. Okay, AgNO3 gives copper nitrate, CuNO3 whole twice plus Ag. Okay, 2 Ag for balancing, and here also 2 silver nitrate. Copper nitrate, it is blue in color, so here also color changes. Silver nitrate, it is colorless. Silver nitrate is colorless. Okay, so here also color changes from colorless to blue. Okay, copper is more reactive, so copper is displacing silver. From silver nitrate we are getting copper nitrate and silver. So this is also another example of displacement reaction. Now for displacement reaction, what you should do, you should learn reactivity series, because that is very very important. Because if you know reactivity series, you can get an idea, or you can make out which element can displace what. Okay, so according to the reactivity series, the first one is potassium. Okay, second one is barium, Ba is barium. Please write down in your notebook reactivity series. Second one is calcium, Ca. Okay, the fourth one is sodium, Na. Then magnesium, Mg. Okay, then aluminium, Al. Okay, next one is zinc, Zn. Okay, then iron, Fe. Okay, next one is nickel, Ni. Nickel is Ni. Fine. And then stannous, Sn. Okay, stannous, that is also known as tin, stannous. Okay, and then lead, Pb. Okay, after lead, hydrogen. Okay, because there's no space, so I'm writing here all those elements, those are below hydrogen. We can start from hydrogen here. Hydrogen, then below hydrogen, next one is your copper, Cu. Okay, after copper, the next one is mercury, that is Hg, and then after mercury, Ag. Okay, so that is silver, and then platinum, Pt, and gold. Okay, remember, Ag is silver, gold is Au. Okay, so you have to learn this reactivity series, then only you can get an idea, or then only you can make out whether the element can displace another element from its compound or salt solution or not. Okay, remember this, children: potassium, barium, calcium, sodium, magnesium. Okay, aluminium, Al is aluminium, zinc, iron, nickel, stannous, lead. Okay, and after that, hydrogen, although it is non-metal, still it's there, because we just now I've shown you one example of metal with acid. So all those metals, those who are above hydrogen, they can displace hydrogen from acids, and below hydrogen, children, copper, mercury, silver, platinum, and gold. This is reactivity series or activity series. Okay, this you have to memorize. Fine. So we'll move to the next type of reaction, that is double displacement reaction. Okay, now what is double displacement reaction, Bitu?